Hello student, welcome to EaseMyStudy YouTube channel. I am with you Abhinandan Kumar Jha. In this class, I am going to start the new topic, electric potential energy. So let's start today's lecture. So whether you are preparing for JEE Mains and NEET examination or any CBSE board, this lecture will definitely helpful for you. So we'll understand what is electric potential energy in this lecture very easily. Definitely I make sure that you will understand the concept easily and you'll be able to solve the numericals also based on this concept. Watch the video completely. So far you haven't subscribed my channel, please subscribe the channel so that you can get another videos on time. But today onwards I will deliver the lectures in English language only. However, for Hindi medium students, the subtitles you can use that in the videos. So first we'll understand what is the electric potential energy and why. Now consider a system of charges. We have a system of charges, say some Q1, Q2, some Q3. So when there is a charges present, they would have the electric field lines near them. Electric field lines near them. So if we move any charges in that field lines, you have to do some work done. Otherwise, because of the field lines, there is a force of attraction or repulsion based on the nature of the charges acting between the charges. So this force you have to overcome to move that charges. So if you want to move the charges, you have to do some work done. And where there is a work, to do work, energy is required. So that negative of work done is equal to the energy, and which is here the electric potential energy. So electric potential energy is basically the negative work done. So if I say that if is du, the change in electric potential energy will be negative of work done. The concept you have understood. Why this work done? Because there is a force of attraction between the charges. The force attraction between or repulsion based on the nature of charges, that forces you have to overcome that. You have to do work. Work is equivalent to the energy itself. To do work, energy is required. So that's why we talk. We will derive the electric potential energy, but as a negative of work done. Understood? So we define change in electric potential energy of the system as negative of the work done by the electric forces as the configuration of the system. We'll define so you see that we define change in electric potential energy of the system as negative of the work done of the electric forces as the configuration of the system changes. So what exactly we are doing it here? We are moving the charges. So here if you want to push these charges somewhere, if you want to push these charges, you want to displace, for example, if you want to displace a charges Q1 and here there is another charge Q2, and if you want to move these charges Q2 to somewhere, some another location, C, say it is at A, it is at B, now you want to move these charges Q2 at A. You can move charges Q1 as well, no issue. So at a time, for simplicity, we are considering only moving one charges. If you move another charges, work done will be done by that charges also. Another charges again work done. So for simplicity, where we are taking only moving one charges, remaining other charges are fixed here. I'll say this is my Q1. So because there is a field lines here, and based on that field line, there is a force of attraction or repulsion based on the nature of the charges. You have to do some work. And here, if you move the charges, for example, in this case from Q2 to C, you have to do work done. So you have to find the work done. That will be negative of that work done will be equal to the electric potential energy. So for simplicity, I am going to consider the system of charges where I am going to consider only two charges, and I am moving one charges, keeping other as constant and fixed. So for an example, let Q1 is fixed. At A, it is fixed, it is not moved. At B, there is another charge Q2. Both are positive charges. We are moving the charges B from B to C. Now there is a distance between these two that you can see it here. And now from B to C also. So if A to B, for example, if I say the distance is R1, and from B to C, the distance is some R2, you can say, and we are considering from the point charges itself, there is one charge is R1, and there is another distance which is R2 in this case. Fine. So there are two charges, Q1 and Q2. Now I have to find that if I move these charges from B to C, what will be the work done, right? So let's see in the next page how to drive that. Here is, you have taken one simple example here. On the screen it is visible. You see the charges at A is given positive charges, at B there was charge Q2. Now it is moved to some another location. Instead of directly going to C, I am going to at some intermediate places at a distance R. Suppose that Q2 has been gone there. Okay. So now if Q2 is there, then what is the distance of the Q2 from A is R. Let's say this is example. Okay. Now I take a very small distance dr to move these charges Q2. Okay. So here in the previous example, this Q2 is now move here somehow. This is my A first charges. Now another charge is B. Now I have moved the charges Q2 here in between, so that I can later put it by integrating. You can go to the C also. So now for a very small distance dr. So from A, it is at given distance, and the distance between this Q2 from the A is R, right? And it is moved a dr distance. So what is the force of attraction between Q1 and Q2? Because force into displacement is the work done. So you know the forces, how to calculate the force, electrical force between. So if you want to for here, what is that? Our AB friend, what is here? AB is equal to R1 and AC is equal to R2. You know. Then what is the force of attraction? Because to find the work done, you need force. Because work done is equal to क्या होता है? Very simple. Force into perpendicular. No. Force into distance. Yeah? Displacement. Force into displacement. Right. So here we'll write. First we have to find the force. That force is 1 by 4 pi epsilon naught into Q1. The first charge, which is fixed. The Q2 and the distance is R square. But it is acting towards AB. Why? Because both charges have the same nature. It will repel. And where you want to see? From away from that. That I have told you in the previous lecture in the Coulomb's law itself. And this force is from the Coulomb's law. So now if I want to find the work done in displacing a small distance dr, right? So how will you find? The total work done in the small displacement dr is क्या है? यहां पर अगर हम लिखेंगे स्मॉल डिस्प्लेसमेंट के लिए हमारा वर्क भी क्या होगा? छोटू होगा, dw. Now if you want to find the dw, then the force into a small displacement dr. So 1 by 4 pi epsilon naught into Q1 Q2 by R square into dr. Now this is the small displacement. If you want to displace the object from where? From B to C, then in displacing the work done as the charge Q2 moves from B to C. B to C is, how will you write? The total work done. So total work done will be by integrating. So if you haven't watched the lecture of if you have some difficulties in understanding the integration, you can watch it. That lecture is available also in the playlist Math Class 12, and link is also given in description or also in the I button. You can watch it, please. Right. So if that was the small work done, so total work done will be the dw, integration of dw. So w is equal to integration of dw, and this will be 1 by 4 pi epsilon naught q1 q2 r square dr, and from where r1 to r2. Okay, we are taking the displacement distance from the point A itself where the charge is fixed, because the electric field will be, we are assuming that the electric field is up from the A up to that the point where you are seeing at q2 at the location dr. Okay, so here some constant is there, 1 by 4 pi epsilon naught q1 q2 constant, and the integration of r1 r2 dr by r square. So this integration, you know, r square का integration क्या होगा, r की power -1 1 by 2 plus 1 हो जाएगा, और you know the formula xn dx xn plus 1 by n plus 1. So from this will be -1 by r, and if it is -1 by r, so you have to put the first the upper limit, then the lower limit, right? So if you put the upper limit, then this is -1 by r2, क्योंकि जब भी हम डेफिनेट इंटीग्रल लिखते हैं तो पहले अपर लिमिट रखते हैं. So -1 by r2 plus 1 by r1, 1 by r1 r2. So this formula will be 1 by 4 pi epsilon naught q1 q2, and this will be 1 by r1 minus 1 by r2, right? Because ये -1 by r1 है ना, so here you write 1 by r2. This is mathematical treatment. -1 by r2. First you have to put in place of r the r2, and then plus 1 by r1, and here 1 by r1 minus r2. This is the case, right? And it is acting towards, and it is work done. There is a scalar quantity, no need to give the direction w. But from the definition of energy, to do the work energy is required. So here you know that the negative, and the beginning I have told you that negative of this work done itself will be the change in potential energy, that you have to find it here. So if you take the minus of this, you will get 1 by 4 pi epsilon naught q1 q2 is the constant, and here the direction will be changed 1 by r2 minus 1 by r1. So instead of write this negative of work done, which is the change in potential energy, which is basically ur2 minus ur1, because you are moving from r1 to r2. So change in potential energy ur2 minus ur1, and this formula you can write q1 q2 any form. You can write 1 by 4 pi epsilon naught 1 by r, what you have got it here, r2 first minus 1 by r. So if you take that this, if the separation between these two charges, it is very far. If r2 is equal to infinity and r1 is equal to infinity, means the separation between q1 and q2 is very high, very high. So in that case, du will be 0. Change in potential energy will be 0. So normally to find the potential energy due to a single charge, we assume that another charge has been moved to, another charge q2 has been moved to the infinite location, that is infinity. So here another special case is there from that. This is general case, more general. Now if you find, suppose if r2 is equal to r and r1 is equal to infinity, in that case what is there? So that your charges that you have moved to infinity, बहुत दूर भेज दिया. So in that case, u r2 minus u r1 will be equal to q1 q2 4 pi epsilon naught, and 1 by r2 is what? R minus 1 by infinity is 0. So no need to write 0, just I am going to write, because 1 upon infinity means very large, it is 0. So this value will be equal to here ur2 minus ur1, and this is basically ur minus u infinity, which is equal to this one. Okay, q1 q2 1 by 4 pi epsilon naught into 1 by r. So from now today onwards, you will use this formula. The electric potential energy due to a charge at a distance of r will be 1 by 4 pi epsilon naught q1 q2 by r. So this is the electrical potential energy due to a point charge q1 and q2, and when the distance between them is r. So it depends on the distance between the two charges, and then you can find electric potential energy. It is a scalar quantity. Now suppose if in any cases more than two charges are present, suppose q3 is present, some q4 is present, then what to do? So if multiple charges are present, you have to form the pairs between the charges. For example, q1 q2 one pair, q2 q3 another pair, q3 q4 another pair, q4 q1 you can form another pairs also. There is another pairs also. You can find also q2 q4 and q1 q3, because q1 q3 will not keep quiet, right? And all these pairs you have to make and you have to add it. So we'll also see some numericals in the next lectures, and where you see the two charges, and we'll take the example of three charges, and we'll see that how many pairs are. If there are three charges, तो 3 में तो कोई डायगोनल ही नहीं बनेगा. देखो ये तो 4 में तो डायगोनल बन जाएगा, लेकिन इसमें कोई डायगोनल बनेगा? आई हैव टोल्ड कि नहीं लेना है, क्योंकि वो चुप थोड़े ना बैठेंगे. और अगर मान लीजिए देयर आर थ्री चार्जेस q1 q2 and q3, then what to do? So q1 q2 q3 are present, so here one pair will be this, another pair, and then third pair will be q1 q3. So total three pairs will be there. Okay, so by this way we can find. The question arises in the mind that, sir, why you are taking the negative of work done? We assume that the charges is at rest, charges is not moving, charges does not acquire any kinetic energy because it is electrostatics. So we can say that definitely whatever work done is there, it goes to the electrical energy itself, not to the kinetic energy. Fine. So we'll do some numericals in the next class. Thank you. See you in the next class.